This is a crash course on Git and GitHub. This walks you through all the basic commands you need to quickly get started as a complete beginner. Just so you know, I do move through the lessons quite quickly, so some of the examples may move super fast. That's because this was originally made for members of my data community I'm mentoring, for a project we were working on together. So adjust the playback speed if needed. But don't worry, I'm also working on an updated version with a slower pace and more lessons you may find useful. So let me know what topics you would love me to include. Let's begin. So let's start by talking about what GitHub is. GitHub's a platform for working on coding projects. So think of it like a database that allows you to save different versions of your projects and collaborate with other developers on it. So for example, if you started a project in 2023 and kept updating it every single month, GitHub allows you to access any version of your project at any time. So if you ever need to go back to a previous version, it's easy to do that. And you don't need to save them on places like Google Drive, AWS, or even your laptop. As long as you have internet connection, GitHub lets you save and track all your project changes in one place. And if you're working on a team project, GitHub makes it easy for everyone to work together. Other developers can copy or clone your project and work on their versions using something called feature branches, and then submit their changes for review. So this avoids someone from overwriting someone else's work. So let's say you're a data analyst studying the customer behavior of an e-commerce store. You can use GitHub to store the data you collect, the SQL scripts you write, and the analysis you perform over time. And as long as you're improving your SQL code, you can save each version of it on GitHub. And if you want to invite more data analysts to help, they can clone your repo and add their own analysis. That way, they can contribute their work safely without overwriting anyone else's work. Imagine you're building a data pipeline for a retail company, and you need to ingest the sales made each day for different stores, and then transform and load the data into a data warehouse. And all the Python code for the pipeline is saved on GitHub. If a pipeline breaks due to an error in your code, you can use GitHub to roll back to a previous version that worked without any issues. Restoring previous working versions of your work is easy because each version is stored on GitHub as a commit. So what is Git? Git is actually the technology that makes GitHub work. It's what makes GitHub able to manage different versions of your projects. So think of it like this. If GitHub is the car, then Git is the engine that makes it run. However, Git actually doesn't need GitHub to work. It's actually a standalone tool you can use on your local machine if you have access to a command line terminal. And you can track your changes, revert to previous versions of your projects, and still collaborate with other developers without an internet connection. So when you're offline, Git allows you to commit changes locally. Then once you're back online, you can sync those changes with GitHub. And Git allows you to download a project from GitHub or other repositories and work on it locally. So imagine you're working on a machine learning project where you need to write some R code for analyzing a large data set and test different models. But you travel frequently with your laptop, and sometimes you find yourself without an internet connection. With Git, you can actually continue working on this code using your laptop even when you're offline. Then once you're back online, you can push your changes into GitHub so that your team members can continue their work using your models. Let's say you're working on an open source project on GitHub. Before making any changes, you first clone the repo into your local machine using Git. Then once you've made your improvements, you commit them locally with Git too. Then if everything looks good, you push the changes to your GitHub fork of the project. Then you can submit a pull request to merge your changes into the main project. So GitHub is the online platform that makes it easy to work with other developers, and Git is the command line tool that makes it easy to manage projects when your machine is offline. So let's set up our GitHub account and Git environment so we can start working on projects. So to create a GitHub account, open your browser and type GitHub. Then click on the first link from GitHub. Click Sign Up button on the top right. Enter your email address. Then enter your password. Choose a username. Then follow the instructions on the screen to verify your account. Once you've done all that, you should now have a GitHub account. Now let's download Git on your machine. Open your browser and type download Git. Then click on your operating system. Mine's Windows, so I'm going to click on Windows. Then click on this link here to download the installer for the latest version available. So once it's downloaded on your machine, open it. Then keep clicking yes, next, and install until you reach this progress bar. So let GitHub download all the things it needs to download. Then once you're done, click finish. You may need to restart your machine so that all the changes are configured on it. I don't need to do it because I've already done it. So once Git bash is open, you should see the terminal look something like this. So Steph is my username, and laptop followed by all of this is the name of my laptop. So if I type ls, that shows all the folders and files in the directory I'm in. At the moment, I'm on my home directory. So that just signals that the download for Git has successfully worked. So let's move on to setting up your GitHub account on Git. Now you need to connect Git with your GitHub account so that you can start managing projects on Git. So to set up your GitHub username, type git config followed by 2 dashes and global and user.name followed by your name and then hit enter. To set up the email linked to your GitHub account, type git config and this time use user email. You can check if this worked by typing git config followed by 2 dashes global, 2 dashes list, and you should see your username and email listed here. So at this point, you've created a GitHub account, installed Git onto your machine, and configured Git with your GitHub credentials. Now you're ready to start managing and collaborating on projects. So let's get into some of the basics you need to know. We'll start by creating a repository on GitHub. So this is just a folder to store your project's files and code into. So go to your GitHub profile, and on the top right of your profile, click the plus sign and then select New Repository. Give your repository a name. I'm going to call it My Data Project. You can add a description so that others know what this repository is for. For example, a simple project to understand how GitHub works. You have the option to make it public or private. If you select private, only you and other collaborators you add to the project can see the content in the repository. If you select public, then anyone can view your repository. I'll just click private so that we're the only ones that can see it for now. Then check this box that says add a README file. So a README file is used to describe what your project's about and other instructions for users that visit it. Then click on create repository. And that's your repository created. So now let's do 2 things. The first thing we'll do is create a file while we're inside GitHub. Then the next thing we'll do is upload a file from our computer into GitHub. So we'll start by creating a file first. Now go to your repository and click on Add File. Then click on Create New File. Let's name this testfile.txt. Then write some content into the text editor like, Hello Stephen. Then click Commit Changes. Add a commit message to describe the changes you've made, like added simple greeting to testfile.txt. Then click Commit Changes. Now, you've created your first file on GitHub and you've made your first commit too. Now, let's upload a file already on our computer into our GitHub repository. First, go to your repository and click on Add File. Then select Upload Files. Drag and drop a file from your computer into the box, or click Choose Your Files and select a file from there. I'm going to select the datetable.csv file. Once you've picked a file, go to Commit Message section and add a commit message. For example, uploaded the date table CSV file. Then click Commit Changes, and that's it. You've now uploaded a file from your computer to GitHub. Awesome. Now, we need to clone the GitHub repository on our local machine. This means downloading a copy of the project on our computer so we can work on it offline. As you can see, it's currently sitting on the web version of GitHub, which is called the remote branch, or the online version. Once all of this is on our computer, we can work with the copy on our computer, which is what we call the local branch, or offline version. So first, open up Git bash on your preferred terminal on your computer. Then navigate into the folder you want to save your project locally. You can do this by typing cd, then space, Then copy the directory path of the folder you want to save your project into. Paste it into the terminal. Now we've navigated into your folder. So now go to your GitHub repository, then click on the green code button at the top right of the repository. Copy the HTTPS URL that appears. Then go back to your terminal and type git clone and then paste the URL. Hit enter. After that, type cd and then the repository name. You should now have your GitHub repository into the folder you've navigated into. If the directory doesn't exist, you can also use Git to create it. So you can use the make directory command to create a folder inside the directory of your choice. So let's open VS Code. You can download this using the link in the description. Otherwise, go to your browser and type download VS Code and follow the installation steps from there. So to open it, just type code into the terminal and hit enter. Then click on open folder and navigate to the directory of the project you've just cloned. Now that we've cloned the repository, let's make changes to our date table file. So as you can see, the months only go up to March. We need to add the next few months and their corresponding numbers and then push those changes back to our GitHub repository. So let's go ahead and add the names and numbers of the next 3 months. So once the file is saved, VS Code may highlight the changes we've made in green, which just means Git has detected the changes we've made to our date tables file. But let's confirm this through the terminal. So we can check this by typing git status. So let me break down each line of the results quickly. So on branch main means we're currently on the main feature branch. Your branch is up to date with origin main means the local branch is in sync with the remote branch. So as far as Git is concerned right now, the repository sitting on our computer looks exactly the same as GitHub. Now here's the important part. Changes not staged for commit. This will list the files we've made changes to but haven't added to the staging area. So in Git, the staging area is a waiting room where all the files we've modified stay until we've committed them. So to add our date table file to the staging area, we need to use the git add command. We can type git add and then add the name of the file, just like this, then hit enter. If you've made changes to multiple files and you want to add them all at once, you can simply type git add full stop. So this will stage all modified files. So if we run git status again, you'll notice the file name is now highlighted in green, which means it's now been added to the staging area. Now, if we want to commit the changes that we've made, we type git commit -m, then add a short descriptive message in quotation marks. So for now, I'll just say added 3 more months to date_table CSV file. Then to push changes to GitHub, type git push origin followed by the name of the branch, which is main in this case. Then go to your GitHub repository in your browser and check the date table file. And you should now see the changes you've made to them. Now let's talk about working with feature branches. Let's imagine a team member has made 2 changes to the GitHub repository and sent a message to us on Slack to let us know, number 1, they've added 2 more months to the date table file. And number 2, they've renamed the file to calendar.csv because they felt the name better reflects the content within the file. So this is what the new file looks like with their changes. So what we need to do is we need to pull the latest changes, then create a new branch, and then merge the corrected changes back to the main branch. Since our colleague has already made the changes, the first step is to pull the latest changes to our local machine. This confirms we have the most up-to-date files on our computer. So open your terminal and then navigate to the project folder using cd, followed by the directory path. Then type git pull origin, followed by the name of the branch you want to pull the latest changes from. So in our case, it's going to be the main branch. So now if we jump in VS Code, we'll see some of the changes our colleague has made to the file. The file's been renamed to calendar, and there are 2 new months spelled incorrectly. So let's create a new branch to correct the spelling mistakes. So a branch, or feature branch, is simply a workspace we can use to make changes to a repository without affecting the main project. So this actually allows multiple developers to work on different features or fixes without overwriting someone else's work. So looking at the file, we can see that Julie is actually meant to be July, and Augustus is meant to be August. So instead of making the changes directly in the main branch, let's create a new branch so that we isolate our changes until they've been approved. So it's actually best practice to create a feature branch to hold any changes you want to make to a project. We do this by typing git checkout followed by a dash and then the letter B. Then give it a self-descriptive name like this. And this command creates the new branch named fixMonthTypo, and then it switches you back to that branch. Now this becomes the active branch. And you can confirm this by using git branch. And you should see that the fixMonthTypo is highlighted in green, which means this is the branch you're in right now. So now that we're in the new branch, let's correct the mistakes. First, we'll change Julie to July, and then we'll change Augustus to August. So the updated file should now look like this. Now that we've made the changes, it's time to stage and commit them into our new branch. So let's check the status of our file. We should see the calendar file listed as modified and highlighted in red, which means the file has been changed, but it hasn't been staged yet. So if we type git add followed by calendar.csv, and then we check the status once again, we should see that the file highlighted in green is now staged. This means we're ready to commit and push this to the remote branch. So let's give this a descriptive message. Then we'll push this to GitHub, and that should be it. So let's now merge these changes into the main branch. So let's switch back to the main branch using git checkout main. Now, if you notice, this is different from the previous git checkout command we just used. The git checkout-b command creates a new branch and switches us to it, while the git checkout command just switches us to the branch we've specified without creating any new ones. After that, use git merge and mention the branch we've made the fix in. So git merge fixMonthTypo in this case. So this will now merge the typo fix into the main branch. Now the final step is now pushing the changes into GitHub so that our changes are reflected online in our remote repository. So use the git push command and hit enter. Then go to your GitHub repository and check the calendar.csv file is now updated with the correct month names. And that should be it. So let's talk about how to resolve conflicts using Git. While we're making updates to the month names in the calendar file, another colleague has also created a branch to update the month format for the same file. Let's have a quick look at our version of the calendar file. Now let's have a quick look at our colleague's version of the same file. So we both need to merge our changes into the main branch. So let's start with merging our changes first. Now let's merge our colleagues' changes. So when we're trying to merge our teammates' changes, we see this conflict error message, which means Git has detected there are two versions of the same file that are conflicting with each other, and it needs your help in deciding how to fix it. So let's have a look at how Git displays the conflicts in VS Code. Now let me break this down for you. The head section with the left pointing arrows is Git telling us where the conflict section begins. Head just means the branch we're currently on. In our case, that's the main branch. So everything between the head and these lines of equals represents our version of the file. So all these equal signs just separates the two versions conflicting with each other. Now this part here is the end of the conflict section. So everything between the line of equals and the update month format branch represents our colleague's version of the same file. Now this conflict exists because Git doesn't actually know which version to go with, and so it's asking us what parts of the file we want to keep and what we want to get rid of. Now here are the options available. Number 1, keep your version. If you want to keep your version, remove all of the conflict markers and delete your colleague's changes too. Or in VS Code, you can click Accept Current Changes to keep your version. Number 2, keep other branches version. If you want to keep your teammates' branches changes, remove the conflict markers and delete your changes instead. Alternatively, you can click Accept Incoming Changes to do the same thing. 3, combine both versions. Sometimes it makes sense to combine both versions. So to do that, click on Accept Both Changes. So for now, we're going to advance with our changes. So let's remove the conflict markers and then the other branches changes. Now let's stage this and then commit this. Git will tell us all conflicts have been resolved, but the merge still needs to be committed. So commit the changes, then push the changes into the remote branch. Go to your GitHub repository and check the commit history. You should see a commit indicating that the conflict has been resolved. And that's it. You've now resolved your first conflict. Awesome. Now let's talk about what a pull request is, why we need them, and how to create them. On real projects, especially in larger projects, you're probably not going to be making changes directly to the main branch. Instead, you'll work on feature branches. That's where you can make and test your changes safely. So once your changes are ready, you'll ask your teammates to review your changes before merging them into the main branch. This is done through a pull request. A pull request, or PR, is a way to ask other members of your team to have a look at the changes you've made. Once they're happy with them, they'll approve it, and then they can be merged into the main branch. So when reviewing your code, your team members will check if it follows the team standards, check if there are any errors, and suggest areas to improve where necessary. Now, before you can make a pull request, your branch must be available on GitHub. Let's imagine we've added September and October to our calendar file, and we've pushed these changes into our GitHub repo. We want to share these changes with our teammates so that they can review them. So go to your GitHub repository, then click on Pull Request tab, or click on the Compare and Pull Request button. You should now see these two branches where one branch is pointing at another. At the moment, the fixed month typo branch is pointing at the main branch, which simply means we want to compare the changes made in the fixed month typo branch with what's currently inside the main branch. So let's provide a title so that others can see what this is about. And in the real world, you would add the users you want to review your pull request so they could be notified of this. So click on Create Pull Request. Now this is the stage where the users you selected as reviewers will inspect your work to see if it matches the expected standards. If they're happy with your changes, they will approve your pull request, which means you can officially merge your branch into the main branch. Otherwise, they will add feedback in the comments on what you need to change before that's possible. So make those updates, commit them, and push them again. These updates will automatically be added into the pull request. So according to this, there are no conflicts between the main branch and our branch. So let's pretend this has been approved by one of our teammates. We can actually go and click on Merge Pull Request and click on Confirm Merge. As you can see, the merge was successful. So once the merge is done, you can delete your branch to keep the repository clean if you no longer need it. Go back to your GitHub repo under the main branch and click on the commit history. You should see a new commit that's linked to the merge along with the description you provided when creating the pull request. This also shows the merge was successful. So we've managed to create a pull request and merge the pull request into the main branch. Awesome. Now, we need to talk about handling mistakes and errors using Git. Mistakes happen in any project. It's when you don't know what steps to take to fix them that can be the problem, especially if it disrupts the flow of the project. So let's go through how to fix common mistakes in Git. So let's start with Git restore. If you've accidentally made some changes to a local file and you don't want them anymore, use this command. Git restore allows you to get rid of any changes that have not been committed yet. So for example, if you've added records into a file that shouldn't be there, all you have to do is run git restore followed by the name of your file. This removes the changes from the file and puts it back to the last committed version. Now we can go back and make the right changes this time. Now let's say we've accidentally added the file into the staging area with those errors. If you just want to drop it from the staging area and keep all the changes, use git restore staged and then the file name. To discard changes in all modified files, run git restored followed by a full stop. Let's move on to the git reset command. Let's say you've already staged and committed a file, but you've realized you've accidentally made a typo in the commit message and you want to undo that commit. To undo the commit and keep your changes, use this command. So head 1 is just the last commit. Head points you to the very last commit. And then the 1 tells Git to move back one commit before that one. Soft keeps the changes in the staging area. So this gives you a chance to correct your commit message and then push the changes once you're ready. But if you want to wipe out your changes on your local machine too, then replace soft with hard instead. But be careful because this will actually delete the commit and the changes you've made permanently. You can't get them back after this, so make sure you know what you're doing if you're selecting this. But what happens if you've made some mistakes on a file and added it to GitHub? Sometimes you accidentally push a file with errors into the remote repository. The safest option in this case would be to use git revert. For example, let's say we've accidentally added incorrect entries to our calendar CSV file and pushed it into GitHub. Now you've only just realized it's wrong, but since you've already pushed it to GitHub, you now need to revert it. To undo this commit without changing the commit history, use git revert head. This is going to open up the text editor called Vim. So let me break down what this is about quickly. The first line is the default commit message for your revert action. This second line just tells you what commit you're reverting. And all these lines that start with hashtags are ignored by Git when you're saving the message. So if you're happy with the default commit message and you don't want to change anything, type : WQ and hit enter to save and quit. Now the mistake has been undone without altering the commit history, and GitHub will track this correction as a new commit. You can also verify if this worked by using git log. So this command will show you the commit history, and you should see a new commit similar to the one you've just saved in the last step. This shows we've successfully reverted the commits we accidentally pushed into GitHub, and we didn't have to alter the commit history too. But don't forget to push these changes into GitHub and check the commit history to see the revert commit appear there too. Now let's dive into Git rebase. In larger projects, commit histories can get messy very quickly, especially when multiple people are working on the same files. Using Git rebase helps us reorganize the commit history so that it's cleaner and easier to read. So let's say you're focused on updating the calendar file and your colleague is focused on updating the README file, and you're both working in your own feature branches. Now, your colleague's changes have been merged into the main branch already, but you want to bring these changes into your branch without creating another merge commit in the process. So let's pull the latest changes from the main remote branch. Then let's now use the rebase command. Now very quickly, let's divert into what Git rebase actually does. So when you use the rebase command, the starting point of your feature branch is moved to follow the latest commit on the main branch. So this means all your feature branches commits are now right after the main branch's commits. This makes it look like your changes were made right after the latest main branch. So let's say the main branch has 3 commits. Now when you create your feature branch, you start from commit B. Now if you noticed, commit C was not included in your branch because that's the commit your colleague created when they were making their changes. And of course, this wouldn't be included in your branch. But the goal is for your branch to include the latest changes from the main branch, meaning you also want commit C added to yours. So when you run git rebase main, you do this. It picks up your commits and then it stacks them on top of C in main or right in front of C. So now your branch will look like this. This makes the branch history look cleaner because doing git merge would create merge commits that could make the commit history a little bit harder to read. But this method could be a pain as well if there are lots of commits and lots of conflicts to resolve. So know when you want to use one over the other. And sometimes conflicts can happen when developers edit the same files on different branches. So resolve them by choosing the correct version of each line in the files, then stage the resolved files. And after staging them, use the git rebase continue command to continue the rebase. So we don't have any conflict, so that's good. Once the rebase is complete, have a look at the commit history using git log one line, and it should look like this. You should see your commit on top of the latest main branch's commit. Now, since rebase rewrites the commit history, you will need to force push the rebase branch to GitHub using the force with lease option. And that should be it. We need to dive into GitHub Actions. If you learn this, you can cut down your development time significantly and work on more interesting parts of your project. So first of all, what is GitHub Actions? GitHub Actions is a platform on GitHub to automate your workflows. So a workflow is a sequence of jobs that are triggered when a specific event happens. Each job is made up of steps, where each step is a specific action GitHub will perform for you. So an example of an event can be when you push a commit to a branch. This event can trigger automated tests, builds, or deployments without you having to do anything manually. So why use GitHub Actions? So first of all, it can save you time. Instead of running the same task manually, GitHub Actions can actually do it for you automatically and much faster too. Number 2, it improves code quality. Because every test and deployment is run automatically, this reduces the chances of human error. This means your code has a better chance of meeting the quality standards you and your team have set for your project. 3, it integrates with GitHub seamlessly. GitHub Actions is on GitHub, and so are all your projects. So you don't actually have to leave GitHub to automate your workflows. 4, it's easy to customize and reuse the workflows. So you can customize your workflows to meet the needs of your projects. And once you've set them up, you can reuse them in other projects to save even more time. And 5, it speeds up development. Now, because your tasks are automated, you get faster feedback on any issues with your code. So this helps you catch bugs early and speeds up the overall development process. In this lesson, we're going to create a basic GitHub Actions workflow. So we're going to have a file that contains the birthdays of our friends. So what this workflow will do is check if our friend Matthew's birthday is included in it. But we want this test to be automated because we have better things to do with our time. So we want GitHub Actions to build the environment and download the libraries we need, test the script to confirm that the birthday was added correctly, and deploy the changes by committing the updated file to the main branch. And this should only run when we push changes into the main branch or someone raises a PR. Now let's start by creating a CSV file that stores the birthdays. We'll name it birthdays.csv. And then let's add in the birthdays of each of our friends. Then commit the changes. Now let's create the Python script that adds a new birthday to the CSV file. We'll name this add_birthday.py. Then add the Python code into the file. And we'll commit these changes too. Now this time, let's add the test script that will make sure Matthew's birthday is correctly added to the birthdays CSV file. So I'm going to name this test_birthday.py. This is going to use PyTest to help us validate the content of the CSV file. And that should be all the Python code we need for this section. Now let's set up the file needed to automate the workflow in GitHub Actions. We'll use a special file called YAML. YAML files are used to define how a workflow should be set up. For GitHub Actions, we use YAML files to define the tasks that should run, the order they should run, and what it should do when they pass the test. So in your GitHub repo, create a new file. Type .github followed by a / to create a subfolder. Then create another subfolder inside it called workflows. Here's where we'll create the YAML file. I'll name it cicd_birthdays.yaml. As you can see, GitHub recognizes we're trying to create a GitHub Actions workflow, so this panel shows up. So now let's focus on the content of our YAML file. I've already written the YAML file to save you time, and here's what it looks like. Now let's break down each part of this workflow. This is the name of the workflow. For the on section, this defines what will trigger our workflow to run. For the push section, the pipeline will run when the code is pushed into the main branch. And for the pull request section, the pipeline will also run when someone makes or updates a pull request. This grants the workflow permission to push changes to the main repository. Without this, the deployed job wouldn't be able to write our changes to the main branch. And under the jobs section, this is where we define the different tasks we want to run. So under build, this is the name we've given the process that builds the project and its dependencies. The test job is responsible for the data validation test, and the deploy job is responsible for pushing the changes to the main branch once the tests have passed. So now let's save this and see how GitHub Actions works. So first, we'll go back to our local repo and pull the new YAML file we've created. Then I'll switch to VS Code, and we should see all the files we've created inside GitHub. We need to make some changes to push into the remote branch to trigger our GitHub Actions workflow. For now, I'm just going to add Sam's birthday into the birthdays CSV file. If you look at the test's birthday file, this checks to see if Matthew's birthday is included inside the file. If the test fails, this is expected because we haven't added Matthew's birthday yet. So let's run this test manually in our terminal to confirm it works. So I'll just go into the terminal and run pytest testbirthday.py. And as you can see, the test did fail. And that's because it couldn't find Matthew's birthday inside our file. So this confirms that it works as we expect it to. But in the real world, we will test so many other parts of the data, so running them manually isn't really fun. So let's use GitHub Actions to run the same test. All we need to do is push these changes into the main branch. Now, if you remember earlier, we said that the GitHub Actions workflow should only run if a change has been pushed into the main branch, which is exactly what we're trying to do now. So let's push our changes, and then go to GitHub. Then let's click on Actions tab, and then click on the job. And as you can see, GitHub Actions is processing each task one at a time. So let's click on the build to see more of it. And these are the steps we defined in our YAML file, and it looks like it's completed them. So let's look at the test job. So this test job failed. If we click into it, we'll be able to see why. And once again, that's because Matthew's birthday wasn't included in the CSV file. So now let's go back to the file and make sure we add Matthew's birthday this time and see if it makes a difference. We can run the add_birthday.py script, but let's just add it manually for now. So add the file to the staging area, then give it a commit message, push the changes into the remote repo. So let's now go back to our GitHub repo and click on Actions tab. Then click on this workflow run. Now let's check how the test performed. And it looks like it's passed the test. So that's how you create a simple GitHub Actions workflow. When you're working on small projects, you can manage your CI/CD workflow inside one YAML file. But as your project grows, it's best practice to split your workflows into separate environments so they are easier to manage once your project keeps growing. So let's start by talking about CI/CD. Now, what is CI/CD? This stands for continuous integration and continuous delivery, or deployment. So let's break this down a little more. Continuous integration is pushing any changes you've made to your code from your branch into a shared repository. This is usually done multiple times a day. In CI, we make sure every change is tested so that we can catch errors early. When you're on a large project, it's better to automate your tests than run them manually so you can save time and effort and avoid accidentally skipping any issues with your code. Some of the tests ran for CI include unit tests, integration tests, and data validation tests. A unit test checks each individual part of our code works as we expect it to. An integration test checks whether each individual part of the program works together properly. And a data validation check confirms data enters the program only in the format we specify. Otherwise, the program would fail. Once the CI tests have passed, changes are pushed into a staging environment for further testing. In continuous delivery, changes require manual approval before going live into production. This is usually done by a quality assurance team. Even though this allows teams to control each release into production, sometimes regulators actually ask for humans to manually review and approve changes so that everyone's confident each change is safe to expose to end users, especially when your automated tests are not 100% reliable yet. Some of the tests you run at this stage include end-to-end testing, UAT testing, and performance tests. End-to-end testing helps us test the entire workflow from start to finish. UAT testing means user acceptance tests. This is getting a group of users to confirm if the program meets their needs or not. Performance tests is checking how well your program runs under different workloads. In continuous deployment, once the changes have passed all tests, the changes are automatically pushed into production without any human intervention. This is useful if you have a reliable testing pipeline you can trust to catch issues. Here, you run things like health checks, monitoring, canary releases, and so much more. You run a health check to quickly find any issues with how your program is performing. Monitoring is similar, but it's more about collecting data to understand how your system behaves over a period of time. A canary release is rolling out a new feature to your users slowly. Instead of releasing a change to everyone at once, you first show a small group of users, like 10%. If everything works fine, you expand it to more users. If there are any issues, you can quickly roll back to the old version before too many users get affected by it. An environment is a place where your code gets deployed to. For CI/CD pipelines, each environment has its own purpose. Each company will name their environments uniquely, but in general, there are 3 environments for CI/CD purposes: development, staging, and production. We'll start with development. This environment is for adding our code changes and testing to see if they work properly. If changes pass our automated tests, they move into the staging branch. If they don't, we fix them until they do. So if you want to create the development environment or the development branch, here are the Git commands for that. The staging environment mirrors the live environment. This is where we check all new features work together without causing any problems that impact the experience of the end users. If they work as expected, then we can promote the changes into production environment. Otherwise, we need to fix any bugs highlighted. So here's the code for creating the branch for this environment. The main branch is our production environment. This is the final version where end users interact with the program that contains all the features that have been tested and approved. So for us to actually understand these concepts further, we're going to create a simple events calendar, which will include family and friends' birthdays, booked appointments, and planned holidays. So I'm just going to create the development and staging branches and then push them into GitHub so that we can begin creating the CI/CD pipelines. So let's now go into GitHub to see if the branches are now there. If I click on the main branch, you can see that the 2 branches we've just created are now on GitHub. And I can also click on branches option here to see the same thing too. We're going to start with the development branch first. But before we do that, we need to set up everything we need to make this work. So I'm just going to switch to the development branch. So let's create the subfolders we need under our main root folder. We need one subfolder for our GitHub Actions workflow, another one to store our data files, one for storing our Python scripts, and another one for our test scripts. We can manually do this in VS Code, or we can use the make directory command to do this in less time and less clicks. Then go to VS Code to check if each folder was created. Inside the data folder, I'll create a file named events.csv and add this data inside. In the source folder, we'll create a Python script to process the events data. Now let's write a test script to check if the system processes the data correctly. So I've written a unit test to check if the event file can be read by the job, and also a simple integration test to confirm if the event summary was generated properly, and a data validation check to confirm if the file contains valid data in the first place. This time, we can create our YAML file to automate this process. So the workflow will first build the libraries we need for the environment, then it will run the tests we wrote in the previous step. If these steps have passed, this will create a pull request and automatically deploy to the staging environment. So let's now push these changes into GitHub. Open up GitHub and click on the Actions tab, and then the job that's running to monitor each stage of the process. So the first job is building our dev environment. And as you can see, it's turned green, which means all the jobs inside it have succeeded. So let's click on the testing stage, and that looks all good too. The final job is now deploying our changes into the staging environment, and that looks all good. So we can double check by entering the staging environment to see if this has worked. And it has. The folders and data we created in the development stage has now been deployed to the staging area. Now let's add more records into the events file, and then we'll push these changes into GitHub to further test if we can update the staging environment automatically. So we'll add Cyprus with family and summer internship interview with bank. Then let's stage this, and then add a commit message, and then push to GitHub. So let's check GitHub Actions to see if jobs are running. Keep monitoring it until all the jobs have passed. Once they're done, we'll enter the staging branch to see if our new records have been added. And there they are. So our CI/CD pipeline for the development branch works just as we expect it to. Now that we've created and tested our CI/CD pipeline for the development branch, let's move on to doing the same thing for the staging branch this time. First, let's switch to the staging branch. Then pull all the latest changes we've made to the staging branch on GitHub. Now let's make some changes to the content of the YAML file. We're going to change the YAML file's name from dev to staging. Then the jobs in the file should include what we want for the staging layer. So I'm just going to copy and paste it in for now. We also need to rename the test file to reflect the environment it's in. So let's change the suffix to staging instead. After that, we need to add the tests that are usually performed in the staging environment, like end-to-end testing, performance tests, and data integrity tests. So once all that's done, let's add them all into GitHub. We're going to see whether GitHub Actions is happy with our changes or not. So let's go into GitHub, and then go into GitHub Actions, and then click on the workflow that's running. Let's wait for the first job to finish. So it shouldn't take too long. So while we're waiting, what we want our staging workflow to do is create a pull request, but not to deploy the changes automatically into the production branch. That's because we want to make sure the QA team take a look at it and make sure each change we've made is approved by them. This happens so that we're releasing stable changes into the environment where the users will interact with our program. So once they're happy with the changes, then we can release them safely by approving and merging the changes manually. So that's great. It's now passed. So let's enter the second one. And as you can see, it's progressing quite quickly through each phase. And now it's passed. So let's now go into the final stage. And that's all the jobs now, which means we should expect a PR when we enter the pull request tab. Just like I mentioned in the previous step, although we're raising pull requests automatically, we want to approve the PR manually so that we're only approving stable changes into the main branch. On the main page of our project, you'll see the pull request tab has a 1 right next to it. That should be the pull request our CI/CD pipeline created for us. So click on the pull request tab, and as you can see, that's the PR the staging workflow created. So click on that. Check the changes under this PR. You can have a look at the commits tab, the checks tab, and even the files change tab. If you're happy with the changes, approve the PR by adding a short comment to show you're happy for the changes to be merged into the main branch. Then click comment. We want the production workflow for the main branch to run after the staging branch merges with the main one. So let's move on to the final environment and set this up. At this point, we've run a bunch of automated tests in the development and staging branches, and we've also manually approved the PR from the previous step. Now, we need to write the YAML file that runs a few final checks before we're confident of releasing the changes for end users to see. So switch to the main branch and pull the latest changes into it. Now let's copy all the folders and files from staging. Okay, let me just correct that part quickly and try that again. Then let's confirm that worked. So we can see the folders and files in VS Code. Then rename the test file. Then I'll just add a simple smoke test to confirm the program's working as we expect it to. So this test will try to run the process event function using the events CSV file in the data folder. Then check if the event summary file it generates is empty. Then after that, it will fail the test if any problems are found with it. Now we need to write the CI/CD workflow for the production layer. I've already done it, so I'm just going to paste it in. Then we can push the new workflow into the main remote branch. This should automatically run the production workflow in GitHub Actions. So go into it to monitor how it goes. The production workflow is finished, so let's go back to the pull request created by the staging environments. And we're going to merge because all the tests have now passed. This merge will trigger the production workflow once again. Go to GitHub Actions tab to monitor the job to see how it's running. You can also run some minor spot checks to make sure everything looks good as well. But there's a problem. When we merged the staging branch into the main branch, we accidentally added some of the staging files into the main branch. So this may have been accidentally skipped when the QA team were reviewing our changes. So let's go and remove these files ourselves so that the end users don't find them. We can manually delete each of the files in VS Code, or we can also use the git remove command to do just that. So let's try out the git remove command for this. Now the files are deleted in our local repo. So let's now push this into GitHub. This will rerun our production workflow again because in our YAML file, we told it to execute the CI/CD pipeline when there's a change pushed into the main branch. Now we can monitor our pipeline to confirm that these changes are good to go. And as you can see, it looks like the pipeline has tested our changes and deployed them into production. And that's it. So we've now created 3 CI/CD pipelines in GitHub Actions. One for the development branch to test new changes with automated tests, one for the staging branch to create a pull request once all changes pass the end-to-end test, and one for the production branch where our changes are deployed to the end users. Awesome. Thanks for watching and I hope you enjoyed it. Subscribe to see more courses dropped on this channel. Stay blessed.